When you find your equations, remember, the key here is the resting line, or the midline as they call it. So, whenever it starts at a 0, it's a sine. If it starts at a 1 or off the 0, it's a cosine. Unless we had a phase shift, but I said don't worry about your phase shifts. So now, this is your regular cosine curve. It hit one complete cycle in 2 pi. That's this one right here. That's your frequency. Your midline is right here. That means it's equal distance up here and here. The distance from here to here measures your amplitude. Your normal amplitude is 1. So if it goes to 2, we times it by 2. And we have no shifts. No horizontal, no vertical shifts, no phase shifts. Now the next guy, find your midline. How do I find my midline? Count from the highest to the lowest. You have 2 spaces. What's half of 2? 1. So it's either going down 1 or up 1. You still get your midline. Now, from this midline, view that. Is that a cosine curve or a sine curve? Did it start at the 0? It started at the 1. So is that a cosine or a sine? Cosine. What's my amplitude? 1. What's my period? 1. What's going to do a whole? Remember, cosine is different. Cosine makes that U. So 1, 0, -1, 0, 1. If I looked at it that way, right, there's my cosine curve. So far, I've got a 1 here, I've got a 1 here. Now, the biggest difference is it used to be here. It used to be here. It used to be here. So now, it moved from here to here. There's my vertical shift up 2. There's my vertical shift up 2. From Ms. Mordecai Moore? Okay, so there's my plus 2. Everybody good with the plus 2? Okay, sine curve. I noticed that my amplitude is still 1. I noticed that I started at 0. So I start like this. So far, so good. There's my amplitude. I have no vertical shifts, so I'm good there. Here's my 2 pi. So let me count. 1, 2, 3. I did 3 cycles in 2 pi. There's my 3. Making sense? Okay, if you didn't get this, are you getting this part now? Okay, I like the equation parts. Some of the other parts are a little tougher, but the equation parts are nice. Whoops. How did I get out of that one? I'm still getting this. Is this the only 6 we had? I'll just do it over here. My resting line. Here's my resting line, right here. So did I move up or down off of my resting line? No vertical shifts. I noticed, did I start at the 0? No, so this is not a sine, this is a cosine. But oddly, my cosine starts up here. What caused me to go down first? A reflection. So there's my reflection, the negative. So 1 complete curve in 2 pi. There's my frequency, 1. Okay, now this one you didn't have to do a shift for. I think we could, no, this one had to have a phase shift. This one had to have a phase shift. Did I tell you that this one had a phase shift? No. Okay. Because if you notice this is where it's peaking. Okay, here's your resting line, right here. So you know you got a +1 up here. This is your +1. So if you got that far, I'm happy. And you got your amplitude, that's 1. But normally, I would start over here. It looks like it's a cosine, right? It looks like a cosine. But cosine, that would have been my highest. This is my highest here. So technically, it's a sine curve. It's a sine curve because it could either shift from that side, -pi here, because it started over here, or you could even shift it to pi over 2 and start it there. So if you didn't get the phase shift, I'm not concerned. I won't give you guys finding an equation with the phase shift. But I just want you to be aware this one couldn't have been a cosine. This guy, well, I must have moved off this line, so let me find. This is 2. Half of 2 is 1. There's my resting line. So from here to here, this is where my -1 came in.
How do you know if it's the difference between a cosine and a reflection because of the sine curve? I thought this one was a sine, like negative sine. I thought that.
Oh, okay, so what made you think negative sign?
Because a regular sign is up, and then that's flipped upside down.
Okay, but what happened is this: you looked at this part, so you saw your 0 there.
Yeah.
But your normal sine curve is 0, 1, 0, -1, 0. It would have went 0, 1, or if I did a negative 0, -1, 0. So find your resting line first. So now, if you look at this resting line, think of that as your baseline, your midline. What kind of curve is this that starts here at the 1? Cosine. Don't judge it off of this because we moved it. Find your resting line and judge it off of that. That's a normal mistake. Because the first thing we always say is, well, if it starts at 0, it's a sine. But always look at your resting line first and just hold the other one so that you don't see it.
Okay.
You know? So, and that's a very, very popular concept to miss. So now we completed 2 in 2 pi. There's my 2. Good? How did we do on the other one? The other one was a little tougher. Yes. But what changed is inside the parentheses. Now, normally when we do a function and it's inside the parentheses, it moves horizontally. It's still going to move horizontally. But with angles, we just call it a phase shift. Because it's kind of hard to say, well, you're moving your angles away from here. So we call this guy a phase shift. And our phase shift still goes the opposite way, so we're going to the left, and this one is always C over B. So pi over 6 over 1, so we're moving to the left, pi over 6. What is pi over 6 in degrees? 30. So if you kind of just extend this out, make this be negative pi over 6. This is where we're going to start. This is the one thing I didn't like about this sheet. But we're going to figure this out. Now, normally our cosine curve does this, and it goes from 0 to 2 pi to make a complete cycle, right? So, and here's what we do. We take x plus pi over 6, we set it equal to 0. We take x plus pi over 6, we set it equal to 2 pi. Because it can't go from 0 to 2 pi anymore, right? Because we said, whoop, move over this way and then start. So, yes, it's going to start at the negative pi over 6. And I'm going to subtract pi over 6 from here. So you're going to have to make 2 pi into a fraction that has a 6 in the denominator. So therefore, this would be 12 pi over 6, right? What is 12 minus 1? So this is going to go to 11 pi over 6, just short of your 2 pi, right here. It's going to stop right there. This is going to be one complete cycle of cosine. So how many quadrants is in a cosine cycle? 4. So let's start. Let's label. Let's go through. This is what you do. You start right here. This is your starting point. Follow this. 1. Every 30 degrees, every 90 degrees. So 90 degrees now throws me off. But how many 30s make a 90? 3. So 1, 2, 3. There's my 0. 1, 2, 3. There's my -1. 1, 2, 3. There's my 0. 1, 2, 3. Oh, look at that. I was supposed to end right there. There's my curve. So there's my complete cycle from here to here. Okay. It's the same as if I would have started at the 0 and went to the 2 pi. But you just said, ooh, walk a little bit to the left, but you still got to go through every 4 quadrants. And every 4 quadrants is 90 degrees. So if you were off by 30, just keep counting 90, 90, 90, which is 3 ticks. Like, I like this because they did put your tick marks. The answer, they don't have your tick marks in this. So I don't like to show you the answer sheet either. Because the answer sheet doesn't have the tick marks. They just went by 90s. So, and they made it a little smaller, so it's a little bit more difficult to see. But this is important right here. This is one complete cycle. What's that? 11 pi over 6. Because we started it, if you think about it, Jeremiah, if you started it 30 degrees to the left, wouldn't you finish 30 degrees before 360, right? Which is 11 pi over 6. Otherwise, it would be 12 pi over 6 for 360. So if we walked it a little bit to the left, we stop a little to the left.
So you subtract pi over 6 from 2 pi?
Both. We're both. We're normally, our normal curve goes from 0 to 2 pi. So we just take whatever's in our phase shift, set it equal to the 0, set it equal to the 2 pi, and that'll give us one complete cycle. So if I start here and I go every 30, wouldn't it make sense that I have to go 30 past this guy, right? So if I started here, back 30, wouldn't it make sense that I'm going to finish 30 before the end? So I still need to do 360 degrees for a cycle. My frequency is still 1. Okay? Make sense? All right, make sure you're able to do this. Do this with me. All right, let's take a look at it. Whoops. Take a look at a couple more. Let's take a look at number 5. This is a good one because we changed the frequency on you here. No phase shift. And we did something else. What does this negative tell me? Reflection, absolutely. So I still start at the 0, but instead of going up, I'm going to go down. So take your sign. Let's multiply it by a -1. So this is what I'm looking at with my reflection. Leave the frequency for a second. And then I'm going to, after I do this, I'm going to take this whole thing and walk it up 1 unit. This is my vertical shift up. So if I do a vertical shift up, doesn't that change your resting line? Didn't it go from y equals 0 to y equals 1? Right? So now my resting line is going to be here. You can think of it that way and do it that way, or you can add 1 to everybody. Oops. 1, 0, 1, 2, 1. And you can graph it from here. Now, the last thing we have to deal with is 3. What does this 3 mean? Frequency. But what does it mean to me? 3 complete cycles in 2 pi. 3 complete cycles in 2 pi. So think of this in degrees for a second for me. If I complete 3 cycles in 360, how much is each cycle going to be? 3 cycles in 360. How much to complete one? 120. I take 2 pi divided by 3, or 360 divided by 3. It takes me 120 degrees. So every 120 degrees, I'm going to make a complete cycle. So here's my first 120. I'm going to make a complete cycle right there. How many quadrants do you go through to make a complete cycle? 4. I take my 120 and I divide it by 4. My quadrants are every 30 degrees. Oh, that works out really nice for me. So, tick, 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 tick. There's 4. 1, 2, 3, 4. There's another. 1, 2, 3, 4. There's another. Now, follow this pattern right here. I'm going to do a 1, then a 0, then a 1. Follow the little tick marks here. Then a 2, then a 1. Look at your resting line. Isn't that your sine curve with the reflection in it? Look at your resting line and look at it, right? Okay, so do this again. I've got a 1, then a 0, then a 1, then a 2, then a 1. Isn't that the second one we're doing? Then do it again. I've got a 1, then a 0, then a 1, then a 2, then a 1. And there's your third one. So you've got 3 complete cycles in 2 pi. Yeah. Do you have questions at all? Okay, let's take a look at number 6. Is it what you had last night? Getting the same kind of things? Alright, so tell me a story about number 6. What's number 6? Why is this different than a regular cosine curve? What was transformed here? Anything you see? Plus pi. So what does this mean to me? Okay, inside the parentheses, think of your regular squaring functions. This is the easiest one to remember it by. Oh, so let's put a plus here. What does the plus 2 mean when it's inside my parentheses? Where was my movement? A horizontal, and it went the opposite way, right? So apply the same thing here, only it's going to go the opposite way. It's going to go horizontally left. Pi units, because this is 1, so C over B, which is pi over 1. So it's going to go horizontally left. We just call this a phase shift. It just means instead of starting this at 0, where am I going to start this at? Negative pi. Good. So if I brought this out here, and I wanted to start this at negative pi, there's my positive pi. Let's say that this is my, let's say for instance that this is my negative pi over 2. Let's say that this is my negative pi. It's going to start out there instead of starting at 0. So we take this guy, and we set this equal to 0. And we take this, and we set this equal to 2 pi. So it's going to start at negative pi, and it's going to go to pi. Negative pi to pi. That's 360 degrees. What's your frequency? 1. So all we have to do now is take your cosine, 1, 0, negative 1, 0, 1, and what is this going to do for me? Good. A vertical shift, it's going to drop at 1, down 1. So let's just subtract 1 from everybody. 0, negative 1, negative 2, negative 1, 0. This is what I'm going to graph. I'm going to start right here at negative pi, 0. And I'm going to go every 90 degrees. Negative 1, negative 2, negative 1, 0. Now, okay, there's my cosine curve. Now, if you weren't able to bring the whole thing backwards, if you realized that you went from negative pi to pi, couldn't you do this? So from negative pi, like I can't do this part, let's say. They only gave me this piece of graph, which they did. So I know it started here and it stopped here. Then it has to go again from here. It's got to go to 2 pi, but it's got to go to 3 pi, right? But can I start here at my thing and say 0, negative 1, negative 2? If I could graph this piece, then could I go backwards and graph this piece here? And connect it, get back to the 0? But just remember, you can't start at 0. You could start at the negative pi, you could start at the pi. But you can't start at 0. Okay, maybe we can squeeze in 1 or 2 more. Did we do 7? No. Okay. But we did one of these. I know we did one of these. Did we do 8, right? We did 8, not 7. Okay, let's do 7. All right. Now, remember yesterday I told you with 8, this is your frequency out here. This is your B. If we distribute it, when we do C over B, it would still reduce down to the same thing. So C over B is still going to reduce down to this. Which way is this phase shift going? Left or right? Right. Pi over 3 units. What is pi over 3 in degrees? 60. Which means I can't start at 0. I'm going to start at, this is 30, this is 60. I'm going to start right here and make my sine curves. Okay. Now, I have no amplitude change. I have no vertical shifts, right? So my sine goes 0, 1, 0, negative 1, 0. But I have to deal with a couple of things here. I now have a frequency of 2, which means I have 2 complete curves in 2 pi. So how long does it take me to make 1 complete curve? What did you say? No. I have 2 in 2 pi. So I want to have, how long does it take me to just make 1 of those? I got to go like this. Make 2. So it's going to take me pi over b. Every pi, every 180. How many quadrants? Let's think this out for a second. How many quadrants in a full cycle? When I go around a unit circle, how many quadrants? 4. So I want to see how long are my quadrants. My quadrants are now 45 degrees apart. This one's got a little bit of an issue. So let's tick off 45 degrees from here. Remember, your tick marks are every 30. So if this is 30 and this is 30, isn't 45 in between? That's 1. There's a 15, there's a 30. That's a 45. There's a 30, there's a 15. So do you see a little pattern here? You're getting 1.5. Aren't you getting 1.5 things? Isn't a 30 and a 15 45? So you got to give me every 1.5. And I got to go a little bit more, and I'd have to keep going a little bit more. So I got a phase shift. So from here, I can start. There's my 0, every one of these tick marks. There's my 1, there's my 0, there's my negative 1, my 0. That's 1 curve. I do it again. 0, 1, 0, negative 1, and I got to come up here, 1.5 marks to my 0. Okay? We had a phase shift. The key point, guys, is once you find your period, if you divide your period divided by 4, that shows you where your tick marks go, because you have to go by 4 quadrants every time. Okay? And can you run this backwards? Absolutely. Just go backwards. 0, then the next one, we had to do 1.5. So there's the 0, there's the negative 1, and if we kept going, we could eventually get it up to where we need to be. Okay? That's probably one of the, well, the one we did yesterday, number 8, that was probably about like the hardest one out here. I think number 10 probably is a little harder. But let's work on just one of these guys over here. I like these guys too. Kind of helps you make the equation at the same time. So you're working off of a sine curve. We're vertically stretching this by a factor of 2. What effect does this have? What am I changing when I vertically stretch this thing by a factor of 2? The amplitude. So right away, I am 2 sine x. Then I translate this thing up 1 unit. What does that mean to me? Plus 1. So here's my sine. 0, 1, 0, negative 1, 0. I amplify it by 2, multiply it by 2. I get 0, 2, 0, negative 2, 0. Add 1 to everybody. I get 1, 3, 1, negative 1, 1. This is what I'm graphing. My period didn't change. I didn't put it anywhere else. So I start 0, I graph 1. At the 90, I graph 3. then I'm 1, then I'm -1, then I'm 1. So here's my sine curve. Where's my resting line? If I went up 2, my resting line moved up 1, right? So my resting line is right here. Does that make sense? Right? Because that's where my sine would start at 0. Yes? Okay. I know you guys are not used to graphing like this, and I don't know really how you learned graphing. I'm not really. Okay. So we pull out our asymptotes, and we say, okay, let's just see how am I going to graph this. We notice that the tangent at the 0 is 0. The tangent at the 180 is 0. So I kind of know where this is going. The tangent at the -pi must be 0, and at the -2pi must be 0. So back to your special triangles. A 45-degree angle. What is the tangent of 45? Oh, right. 1 over radical 2. So the tangent is 1. So if this is my 45, the tangent is 1. And if I go negative, my tangent is -1. So my tangent curve, if you will, is going like this. So for each one of these little sections, it goes like this. So again, this is my tangent. Kind of gets blocked off a little bit. So if it keeps on going in both directions, what is my range for tangent? -infinity to infinity. Good. Now my domain is special because it stops. It has different places we have to stop at those asymptotes. So this is how we define your domain. We say real except when x is equal to n pi over 2, where n is an odd integer. We say, can't use those asymptotes, right? But you can use anything else you want, but you can't use the 1 pi over 2, the 3 pi over 2, the 5 pi over 2, the 9 pi over 2, any odd n value. So that's how we describe the domain for this guy. And this is how I want you to remember it. Okay? Not a lot that we do with tangent. We can shift it. We can do a phase shift. If we want, we can shift it. We can't really change its amplitude. We can change its period. Now, cosine and sine had a period of 2 pi. How long does it take me to complete one of those little squiggle sections? Pi. Good. So the period for tangent is pi. If you notice, it's kind of like built right in here. Kind of like a built-in barrier. Every little section is like a little barrier. Just this piece, just this piece. So from -2 pi, negative pi over 2 to positive pi over 2, God bless you, it's one full cycle. So the period is pi. Amplitude, no amplitude. So we can change its period, we can stretch it out, we can shrink it in, and we'll do that. But right now, everybody okay with the domain and the range? Okay, let's look at cotangent. I'm going to pass your other ones, and we're going to go down to cotangent. Oh, it was the first one. Thank you. Oh, perfect. Thank you. Okay, so around your unit circle again. You notice I always live with this. This is like my go-to thing, my unit circle. Because these give you your maximums, your minimums, and your zeros. Now, tangent was y over x, but cotangent is x over y. So now tell me, which one of those quadrant angles will have a problem and not be able to get a cotangent? 180. And where? 180 here, and then where else? Here. At the 0, right? Because what happens when we take x over y, whoops, can't do that. Negative 1 over 0, whoops, can't do that. So now our asymptotes are at the 0, at the pi, where else do you think? 2 pi, okay, negative pi, negative 2 pi. So our asymptotes, let's take a look at the pattern here. 0 pi, 1 pi, 2 pi. What would come next? 3 pi, 4 pi, negative 1 pi, negative 2 pi. So how can I generalize this? At the n pi, where n is now any integer. This is where my asymptotes fall. So you can tell me 5 pi, 6 pi, 7 pi, 8 pi. Those are where my asymptotes fall. Now I noticed, now the opposite ones have the zeros. The 90, the 270, these have the zeros. And again, what is the cotangent of 45? If the tangent of 45 is 1, what is the cotangent of 45? 1. So here's my 45, there's my cotangent. There's my, in quadrant 2. So my cotangent curve goes like this. Okay? It's looking like this. It shifts the opposite way of a tangent, and it has different asymptotes. Almost there. So the period again of my cotangent curve is pi. It's kind of more obvious now because it's between 0 and pi, right? Okay, so we're going to define its domain as real, except when I hit those asymptotes. N pi, where n is any integer. What's the range? All real numbers. I can hit any number on my cotangent. The reciprocals and the tangent, they don't work like the normal curves do. They're not continuous. They have little problems in there. But we can look at them differently. Now tomorrow we'll look at the other two. So tonight, just kind of review these two and see where we're going with this.